In Chapter 5, we're going to be talking about a new type of function called a quadratic. And a quadratic, you would have seen this before in Algebra 1, quadratics are equations or functions where the biggest exponent we have is an x squared. So basically, when you picture quadratic, think of x squared. The form we're going to be writing quadratics in is written in red here. We have y equals ax squared plus bx plus c. That's pretty common. It's actually called standard form, and I'll define that. Well, you know what? I'll write that down now. This red guy right here is called standard form for a quadratic. And that's something that we'll come back to again and again in this chapter. The big difference, though, what actually makes this quadratic is this first guy right here with the x, this exponent of x squared. So our variable is not just a plain old x, like it has been all year long so far. We actually have an exponent on our variable, an exponent of 2. So our different terms here are called the quadratic term, because it's the part with the x squared, the linear term, because it's just plain x right there, and the constant term right there. And one more thing on this, if you notice off to the side here, I wrote down that a can't equal 0. In class, I would have you guys think about why that was and give me some ideas. So over the video, just kind of take a second, maybe pause the video and think about why we even bother to say that. Because I'm going to tell you the answer right now. You can't have a equal to 0, because if you do, 0 times x squared, that's just going to go away. This whole piece would kind of cancel, and you just get bx plus c. It's not a quadratic anymore. So a can't be 0, because it would kill off the quadratic piece. So all I want to do in this first video here is talk about whether these two examples down here are quadratic or not. So when you're looking at something, it's not always easy to see if it's quadratic if it's not written in standard form like we have up here in red. So all I'm going to do here is simplify, combine like terms and stuff, and see what I end up with. So I get negative 3x squared minus 6x. If I distribute and then I carry down my minus 7, that is indeed a quadratic. There's my a, b, c, x squared, x, constants. So this is definitely a quadratic. On my second example, it's the same sort of deal. I'm just going to distribute. I'll get 4x squared minus 28. That's looking pretty good so far. I do have an x squared term. And I have just a minus x. That's like a minus 1x here. So I'm going to get minus x times x squared makes x to the third. And then we get minus 6x squared when we distribute against the last guy. So I'm going to combine my like terms now. And I'm going to put my exponents with variables going descending. So I'm going to put my x to the third first. That's my biggest exponents. I can combine like terms. I have 4x squared minus 6x squared. That's minus 2x squared. I don't have a regular x term. And then I have just minus 28. This is not a quadratic. This is actually a cubic function because my biggest exponent is x to the third. The biggest exponent you can have is 2 when you have a quadratic. So this is not a quadratic function.